Hey, what's going on, guys? Let's do this problem right here. The question is asking evaluate the following telescoping series. So the first thing we can do is we can try to write this one in a summation notation, right? So let's see what is the pattern this series have. First, if you look at this one, this is increasing by 1, and also the multiplication also increasing by 1. And if I want to write this one in summation notation, this is going to be n is starting from 1, right? N is 1 going to, it's like going forever, so infinity. And then we are going to have 5 on top. In the bottom, if it's starting with n is equal to 1, this is n. And if I add n plus 2, right, n plus 2, that's going to give us this value 3, right? And if as we increase this one by 1, this is going to change, like this is going to be 2, this is going to be 4, so it's going like this. So we wrote this pattern right here. So let's see what we can do with this one. So the one thing we can do is we can do the partial fraction decomposition to evaluate this one. So here what I can do, I take this part right along. This is going to be 5 over n times n plus 2, and if we do the partial fraction decomposition, this is going to be a over n plus b over n plus 2, right? So to get rid of this denominator, I can multiply this value both sides. So I multiply both sides by n times n plus 2. So this is going to be n times n plus 2 right here, and the other side also n times n plus 2. If I multiply both sides, this is going to cancel all together. That's going to give us just 5. And the other side, this n is going to cancel. N plus 2 is going to remain with a. So that's going to be a times n plus 2. And for b, n plus 2 is going to cancel. N is going to remain. So that's going to be b times n. So here you can do two things. You can compare coefficients. So you can plug the value to get rid of one of them and find the other one. So let's plug some of the value and find the a and b. So if you want to find a, which value you should plug to get rid of the b? If you put 0, we can get rid of the b, right? If I put 0 for n value, b will be eliminated, a will be remaining, and we can find a. So let's say n is equal to 0. If n is equal to 0, this is 0. So we are going to have 2a is equal to 5. 2a is equal to 5. A is going to be equal to 5 by 2. So that's for a. And if I want to calculate b, I have to get rid of the a. Which value do I have to plug for n to get rid of this a? If I plug negative 2, this is going to become 0, right? Negative 2 plus 2, that's going to become 0. Then a will be eliminated. We can find the b. So this I choose n is equal to negative 2. And then this is going to be negative 2, b is equal to 5, then b is equal to negative 5 over 2. Now we can go ahead and rewrite this same function in different format. That is, let's write this right here. So this is same as a value is 5 by 2, so 5 by 2 over n plus b value, that is negative 5 by 2, negative 5 by 2 over n plus 2, right? So that is same as this one. Now what we can do is we can bring the sigma notation back and bring the sigma notation back and plug these values. So here, if I want to bring this one back, same thing. So if you notice 5 by 2 is common, I can take it to front of the sigma. So this one is 5 by 2, so let's separate this one. 5 by 2 in front of the sigma, and we are going to have 1 over n plus negative, it's actually minus. So here we are going to have minus 1 over n plus 2, and n is going from 1 to infinity, right? Now let's see what we can do right here. So here we can do one thing. We can use the partial sum and see the relationship. Like if we plug For example, let's say this is going until 4 and see what we get, right? Let's plug n until 4 values. So if I plug 1 for n value, this is going to be just 1 over 1 minus 1 over 3, right? Then if I plug 2 for n, this is going to be 1 over 2 minus 1 over 4. And if I plug 3 for n, this is going to be 1 over 3 minus 1 over 5, right? And if I plug 4 for n value, that's going to be 1 over 4 minus 1 over 6, right? So it's going like this. So sigma, this is we got n is equal to 1 to let's say k, but here it's actually 4, it's supposed to be 4, but let's say k, I'm trying to find a generic formula for this one. So here that is equal to this, right? So let's see what are the things that's cancelling here. If you look at this one, we had 1 over 3, negative 1 over 3, and here 1 over 3 cancels each other, and negative 1 over 4, 1 over 4 cancels. Then what else? That's the only thing. So we are left with 1 plus half minus 1 over 5 minus 1 over 6. As you increase one value, so if I put 1 over 5 and 1 over 7, this 1 over 5 cancels and 1 over 7 is going to remain. So the pattern is going to be like, so what's going to happen? Let's create a pattern. 1 plus half is going to always remain the same. As the value increases more than 2 in the denominator, it's cancelling, right? So that's the pattern. So let's write it in terms of k. So let's see what happens if we have k number. This is happening for 4. So let's rewrite this one in terms of k. 1 plus half always remains the same. As you increase the value, if it's k, like here we had 4 right now, we are plugging under 4. So if we have 4, we have 4 plus 1 in the bottom. So 1 over, so if it's k, it's going to be k plus 1. Then if it's 4, it's going to be 4 plus 6 right here. I mean 4 plus 2 right here. So if it's k, it's going to be 1 over k plus 2. So this is the pattern. As you increase, like let's say if you put 1 over 5 minus 1 over 7, what's going to happen? 1 over 5 cancels and you will get the same pattern again, because 1 over 6 and 1 over 7 are remaining. That's also k plus 1, k plus 2. So that's the pattern we are going to have. So if it's k number, we are going to have k plus 1, k plus 2. So this is the equation. So we are only dealing with this part, right? Don't forget we have 5 over 2 right here. We deal with this one separately. So let's go ahead and take the limit for this one and see what we get, right? As limit n approaches infinity. So here we are trying putting in terms of k. So let's say k approaches infinity. K approaches infinity. What's this value is going to be? 1 plus half minus 1 over k plus 1 minus 1 over k plus 2. So if you notice, 1 plus half is going to remain the same. It doesn't change. As k approaches infinity, if we plug infinity for this value, this is going to make this one 0, because 1 divided by infinity is 0, and again 1 divided by infinity is 0. So this seems like 1 plus half remains and others are going to be 0, right? So this is the value we are going to get as it approaches infinity. So this is going to be 1 plus half, that's same as 3 by 2, right? So now we have dealt with this part right here, but we have a pi by 2 right now. So all we have to do is just multiply this one by 5 by 2, and that's going to give us the series, the addition of series. So here 3 times 5, 15 over 4, right? So the series is going to add up to this value at the end. So that's how we do the evaluation for the telescoping series. I hope you guys find this video helpful. See you next time.